there are there are 7 fundamental quantities. There are 7 fundamental quantities. There are 7 fundamental quantities. There are 7 fundamental quantities, which are also known as basic quantities. Which are also known as basic quantities. Which are also known as basic quantities. They are, carefully write, mass, kilogram, length in meters, time in seconds, like that. Right? Mass, length, time, thermodynamic temperature, electric current, substance of matter, luminous intensity. Substance of matter, luminous intensity. Okay. Kilogram, second, meter, Kelvin, capital K, electric current, ampere, substance of matter, mole, luminous intensity, candela, CD. Luminous intensity, candela, CD. Okay. Right. Okay, no? Mass, length, time, thermodynamic temperature, electric current, substance of matter, luminous intensity. Next line, right? There are 2 supplementary quantities. There are 2 supplementary quantities. There are 2 supplementary quantities. They are, there are 2 supplementary quantities. They are, right? First one, plane angle. First one, plane angle. You can put radian. Second one, solid angle. Second one, solid angle. Steradian. Plane angle. Radian. Second one, solid angle. Steradian. Okay, no? Right. So 7 fundamental quantities. Quickly tell. What are your fundamental quantities? Mass, length, time, thermodynamic temperature, electric current, substance of matter, luminous intensity. 2 supplementary quantities. What are they? Plane angle, solid angle. Right. Now look at this. Now, all your life you have been measured using what? Degrees. Now, what is this new story called? Radians. Well, there's a small connection. Relationship between degrees and radians. Relationship between degrees and radians. What's the relationship? Very simple. Pi radians is equal to 108 degrees. Now, what's this pi? The same pi you learned in 2 pi r, 22 divided by 7. Pi r squared, 22 divided by 7. pi radian is 180 degrees. So this is your relationship. Right. Now, what if they ask you to do a small conversion? For example, they'll ask you to convert 10 degrees to radians. 10 degrees to radians. How will you do this? Very simple. So you all know from O level time, 180 degrees is pi radians. 10 toffee is 100 rupee. 1 toffee is how much? There's no toffee here. I'm just telling. 180 degrees is pi radian. 1 degree is how much? Pi over 180. Here, pi over 180. What are they asking you? 10 degrees. So 1 toffee so much means 10 toffees you multiply by, there you go. 180 multiplied by 10. 0, 0 cancel off. What's your answer? Pi over 18 radians. I know some of you will say, sir, why can't we substitute 22 divided by 7? No. Normal standard notation is we keep in terms of pi. So all your radian answers keep in terms of pi. Pi over 18, pi over whatever. Is it? So here, one example I have done. Maybe another example I'll do. Let's say they will ask you to convert 5 degrees to radians. So how will you do? 180 degrees, pi radians. 1 degree, how much? Pi over 180. 5 degrees, pi over 180 multiplied by 5. Simplify this. Pi divided by, here you have 5 times how much? 3. 30, you have what? 6. Pi over 36 radians. You know? So you can convert degrees to radians. Okay. What if they ask you to convert radians to degrees? For example, they'll ask you to convert pi over 2 radians to degrees. How will you do? Simple. Pi radian is 180 degrees. So what do you mean by pi divided pi over 2? This side or side divided by 2, O-level maths. Other side or side must divided by 2. So here pi over 2 radians. On the other side, 180 over 2. This side I divide by 2, other side divide by 2. Okay. So 180 over 2 means how much? 90 degrees. Pi over 2 radians is equal to 90 degrees. Understood? Yeah. Another example. Let's say pi over 5 radians. Convert to degrees. How? Pi radian equals 180 degrees. Divide both sides by 5. Pi over 5 radians equals 180 divided by 5. Side I divide by 5, that side I divide by 5. What's your answer? 3, 6. Pi over 5 radians is what? 36 degrees. So now you know how to convert degrees to radians and also what? Radians to degrees. Okay, no? It's right. Relationship between degrees and radians. 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 That's right. Look like pi radians equal 180 degrees. Pi radians equals 180 degrees. Pi radians equals 180 degrees. Okay. Write this example. Example number 1. Example number 2. Small example. I'll give a lot later in a while. Now write these examples. Okay. Example 1, example 2, example number 1, example number 2. Put the units are radian, here radian. Put the units. So 5 degree equals pi over 36 radian. Pi over 36 radian. Okay. Anybody still writing this? No one? Okay. Example 3, example 4. Converting radians to degrees. Converting radians to degrees. That's easy. You are dividing both sides, you get the answer. Write down example 3, example 4. Okay, now finished. So I'll give you some a small exercise for you all to do. Converting degrees to radians and then radians to degrees. Okay. Anybody still writing? Anybody? No one, no? Right. So convert to radians. Convert to radians. Right. 15 degrees convert to radians. 30, 45, 60, 75, 120, convert to radians. Right. Quick conversions. Now, if you look back, everything you converted to degrees or radians, you multiply it by a factor pi over 180. Pi over 180. So same way here. Everything should be multiplied by a factor pi over 180 times 50. What's your answer? Pi 112. Pi over 12 radians. Here also, pi over 180 multiplied by 30. How much? Pi over 6 radians. Here, pi over 180 multiplied by 45. Pi over 4 radians. Okay, no? Pi over 180 multiplied by 60. How much? Pi over 3 radians. Pi over 180 multiplied by 75. At once you can solve this. You can divide. Normally, remember 2, 3, 5. From there, you can divide. Divide by 2, divide by 3, up and down, divide by 5, up and down. Like that, bring it to the smallest factor. Now, how old are you all? 16 years. 17. That means by now you should know the 15 table. One table every year. Yeah. 15 times 5, 15 times 12. Answer is 5 pi over 12. See whether you got this. Okay, no? Even if you can't get this, divide by 3, divide by 5 and get this. Smaller factor. Okay. Pi over 180 multiplied by 20, 60 times 2, 60 times 3. 2 over 3 radians. Look, pi over 180 multiplied by 150. You can divide by 3. 5 pi divided by 6. Here, pi over 180 multiplied by 225. You can divide by 15 and again you have to divide by 15. So here, pi divided by 4. If you divide and get pi over 180 multiplied by 270. How much? 3 pi divided by 2. You can divide top by 90 and 90. 90 times 3, 90 times 2. Or you divide and go. 0, 0 cancel off. 3 times 9, 3 times 6. Or 9 times 3, 9 times 2. Same answer. Pi over 180 multiplied by 350. How much? From this 7 pi, no? 7 pi divided by 4 radians. Now you can see the whole idea behind speed is sometimes dividing quickly, multiplying quickly, adding quickly. The speed means that doing the calculation part quickly. Okay. So right, convert to radians. Anybody still writing this? Is there anybody writing this still? No one. Next one. Convert to radians. Sorry, convert to degrees. Convert to degrees. Right. Quickly convert. Quickly work. Convert to degrees. This is easier compared to converting to radian. This is easier. No, wrong. If you right? Huh? Don't. Standard way. Don't keep decimal form. Keep in fraction. I mean fraction. Correct? It's not wrong. Not wrong. But standard way. Don't keep. Okay. Okay. Right. I'm sure you have done it. Now, reminder, how did you do this? How did we convert radians to degrees? So you divide both sides. So you are dividing whatever dividing here, your same thing you divide there, 180. Whatever you're dividing here, same thing you divide there. So here, 180 divided by 12. How much? 15 degrees, no? Okay. 180 divided by 3. How much? 60. 180 divided by 5. How much? 36. 180 divided by 8. How much? 22.5. Here, 180 multiplied by 3 divided by 4. How much? Here we have 45. 45 times 3. 135. No? 135. You all got this? Here, multiply by 180 divided by 12. 15 times 5 is 75 degrees. I hope you all got this. Here, 180 divided by 9, 20 degrees. 180 divided by 10, 18 degrees. See whether you got this. People who got this, put your hands up. Right now. Here, 180 divided by 15, how much? I gave something else, so I didn't repeat this. 1 here, so therefore 12. 12 degrees. Here, 180 divided by 18, how much? 10 degrees. So whatever they give in degrees, you can convert to radians. Whatever they give in radians, you can now convert to degrees. What should you remember? Just a simple equation. What is it? Pi radian equals 180 degrees. So you have learned 7 fundamental quantities, 2 supplementary quantities, how to convert degrees to radians and radians to degrees. 3 things. Right. People are writing quickly, right? Okay. Right. Anybody still writing this? Anybody? No. Okay. Look at the board now. Where are we going to use this radian connections? Now the combined math students, of course, will learn this in detail in most of your trick problems. We use in radian pure maths. Remember, this looks like a slice of pizza, no? Pick one slice of pizza. Here radius R, here radius R. This angle here is called what? Theta. This length here, I'll draw in red. What do you call it? Arc length. This is called arc length. Symbol is S. What is the connection between radius theta and arc length? Some of you all might not know. It's okay. The connection is S equals R theta. Yeah. S equals R theta. So S is arc length. One of the radiuses multiplied by theta. Theta should be in radians. You can't put in degrees. Understood? So only when theta is in radian, you can substitute here and get the answer for S. S is called arc length. S equals R theta. Okay. Right. Let's write it. The arc length can be found using the following relationship. The arc length can be found The arc length can be found using the following relationship. The arc length can be found using the following relationship. S equal RT. Put pelu. S equal R theta. Anything. There's no problem there. S equal RT. Draw the sector with the arc length. Okay. Right. So what have you learned? 7 fundamental quantities, 2 supplementary quantities, how to convert degrees to radians, radians to degrees. You now know what how to find the arc length. Arc length is S equal R theta. Theta you substitute always in what? Radians. And remember R is the radius. Huh? R is radius. R is the radius. Okay, no? R is the radius. Right. Now look. Using the fundamental quantities, we make new physical quantities. Using the fundamental quantities, we are going to make what? New physical quantities. We call those quantities as what? Derived quantities. Is it clear? We call those quantities are what? Derived quantities. Right. Careful look. We'll start with few examples. Derived quantities. Look at the board. I'll start with a simple example. Area. What is area? Length into breadth. In other words, you are multiplying how many lengths? Answer. Area means you are multiplying how many lengths? 2 lengths. So length multiplied by another length. What is length? No, wait. What is length? There. What is length? Length is a fundamental quantity. Using the fundamental quantity, I have made a new physical quantity. That quantity is called what? Derived quantity. Using fundamental quantities, I am making a new physical quantity that's called what? Derived quantity. Now here, I'll put in meters. Here you go. Length in meters. Here meters. What's your unit? Meter. Indices. If the bases are same, when you multiply, the powers will add. So here meter square. Look at the board. Huh? Second one. Volume. What is volume now? Quickly tell. You are multiplying how many lengths? 3 lengths. Length is a fundamental quantity. Using fundamental quantity, I am making volume. Volume is what? What quantity? Volume is what? Derived quantity. Here meter. This is going to be what? Meter cube. Look at this. Third one. This might be new for you. Huh? Linear density. You will say, sir, I know the density is mass over volume. No. Linear density. Linear density is mass divided by length. Mass is fundamental. Length is fundamental. This is derived. Using fundamental, I am making a new physical quantity. That physical quantity is called what? Derived quantity. Here I measure mass, kilograms, length in meters. If I take this to the top, what's your unit? Kilogram per meter. Yeah. kilogram per meter. I'll teach you later how to put the rules. For now, just get this in your head, kilogram per meter. Right. Fourth one, surface density. Linear density is mass over length. Surface density, somebody can guess, mass over area. Very good. Mass, fundamental. Area, I can find using fundamental. Surface density is what quantity? Surface density is what quantity? Derived quantity. Here you go. Mass is measured in kilogram, area in meter squared. Take on top kgm minus 2. Kgm minus 2. And you're wondering, sir, where the density we learned? That's called volume density. Some people just call it also density. If you just call it density also, it's volume density. Clear? Mass divided by what? Volume. Now volume I can find using fundamental. Mass is fundamental. This is what? Derived. So if I put the units, here kilogram, here meter cube, take on top kg m minus 3. Kg m minus 3. Question number 6. Oh, sixth one, sorry. Here, speed. What is speed? Tell me the equation. Distance over time. Distance divided by time. What is distance? Distance is a length. Length is fundamental. Time is also what? Fundamental. Using fundamental quantities, we have what? Derived quantity. So speed is what? A derived quantity. There you go. Meter here, second there, take on top. What is it? Meter per second. Meter per second. Seventh one. Velocity. Tell me. What's the equation? Tell. Displacement over time. What is displacement? Displacement is a length. Length is fundamental. Time is anyway fundamental. So here, using fundamental, I'm getting a derived quantity. Units are meters per second. Right. That's your seventh one. Eighth one. What is acceleration? Quick tell. What is acceleration? Right. Most of you all say velocity over time. I'll tell you the correct one. Change in velocity divided by time. Is it O level? Yes, velocity over time is okay when it comes to A level. Change in velocity. Change in velocity divided by time. Now, change in velocity is also velocity. Velocity is derived. I'm finding using fundamental. These also fundamental. So that's derived. So meters per second divided by second, take on top. Don't cut it. Take on top. What's your answer? ms minus 2. Very good. Next one. Ninth one. Force. You all can tell me the equation. What's the force equation? Mass into acceleration. Mass multiplied by acceleration. Mass is fundamental. Acceleration I can find using fundamental. So force is a derived quantity. If I put the units, kilogram here, ms minus 2. Now you will say, sir, Newton, no. Newton is a single name given. In this part, we'll just focus on the basic units. What do you mean by basic units? Kilogram, meter, second, Kelvin, whatever. Is it clear? We'll write in basic units. Then Pascal, Hertz, Newton, those things we can quickly what? Is it clear? These are your basic units. Right. Next one. 10th one. Work done. Tell me the equation. Force into O level time, force into distance, except A level. Force into displacement. Okay, no? So O level and A level, slight changes are there. Accepting changes are there. Right? Force into displacement. Right. Force using fundamental we can find. I'll put the units. kg ms minus 2. Displacement is meters. Quickly look and tell me what's the answer. Meter becomes meter squared. Very good. So what's your unit? kg m squared s minus 2. Yeah. kg m squared s minus 2. For now, you just write the basic units. Don't think too much about the rules. 11.1. Moment of a force. Moment of a force. And remember, clockwise moments, anti-clockwise moments, you remember? Tell me, what's the equation? Force into perpendicular distance. And remember, force multiplied by, see, 2 weeks ago you wrote, now everything forgotten. Force multiplied by perpendicular distance. Perpendicular distance to point of rotation or to pivot point. Either way, okay. Right. So force kg ms minus 2, distance is m, becomes meter squared. So kg m squared s minus 2. Here, kg m squared s minus 2. 12th one. I'm only using things that you know today. Next week, we'll put new things. Is it clear? 12th one. Gravitational what? Potential energy. But acceleration will come here now. Short form GPE. What's the equation? Huh? mgh. Mass into acceleration due to gravity into what? Height. Mass. Acceleration due to gravity is acceleration. Acceleration I can find using fundamental quantities. Acceleration due to gravity. Acceleration due to gravity into height. If I put the units, look at the board. kg ms minus 2 into m. So here m becomes m squared. kg m squared s minus 2. Here, kg m squared s minus 2. Just put the basic units and go. Right. 13th. Work done, GP done. Kinetic energy. What's the equation? Half into mass into velocity squared. Right, very good. Tell me now, what is the unit of half? Half unit, not the value. What's the unit? Half unit is half. Half has no unit. Unitless. Values are unitless. Unitless means the answer you put is 1. Now don't go and say, sir taught half is equal to 1. I never taught half is equal to 1. Unit of half is not there. Unitless means it is equal to how much? 1. So half, pi over 4, 3 over 2, 2 pi over 3. Have you ever imagined? Circumference 2 pi r. We put the unit meter. So radius is in meter, answer is in meter. 2 pi, no units. Today only some of you are realizing that. Yes, no. 2 pi, no unit. No unit means 1. Area, pi r squared, meter squared. R is meter, meter squared you get. Then pi, no unit, 1. 1 times m squared is m squared. Yeah. So unit plus 1, mass is in kilogram, velocity is ms minus 1 squared. Now O-level indices, kg, m squared, how much? S minus 2. So this is a small special note there. Values are unitless. Unitless means it's going to be what? 1. Yeah. Unitless means it's going to be equal to 1. Two more things that you all know. O-level. Of the phone will. Pressure. Pressure is also known as what? Stress. Like ambulance, no mean that sound. Pressure is also known as stress. Stress, not the stress that you have or had. This is what? Physical force stress. Pressure is force divided by area. Force I can find using fundamental. Kg ms minus 2. Area is meter squared. 1 m cancel off. What's your unit? Kg m minus 1 s minus 2. Okay, no? There you go. 15th one. Something that you all know. Frequency. And remember, O-level science under waves. Teacher will keep the ceiling key and all and dance. Yes. 1 over periodic time. 1 over periodic time. 1 value. Value means no unit. No unit means how much? 1. Here 1. Time is S. Take on top. How much? S minus. What do you call this? What do you call whatever you learn now? Derived quantities. You're using fundamental quantities to make new physical quantities. So today, whatever you know from O levels only, I wrote on the board. Those days you didn't know they were derived. They were there, you learned. Why you learned? Teacher taught, I learned. Now you know the meaning why you learn. Because they are very important. They are connected to what? Your fundamental measurements. Okay, no? Let's write. Derived quantities. Derived quantities. Okay. Using fundamental quantities, we can make new physical quantities. Using fundamental quantities, we can make new physical quantities. We can make new physical quantities. They are called derived quantities. They are called derived quantities. They are called derived quantities. Right, start. Start a bit quickly now. Area, volume, linear density. So it initially start off 10:30, 12:30 or 12:45. I don't finish on time. Huh? You can ask from your seniors, they will tell that. Is it clear? So don't tell your parents to exactly come at 12:30 because I will never leave at 12. Whatever I started, I finished teaching and send. Okay? Normally 12:30 means 12:45. Okay? Okay, no? About the senior batch today morning 7. So like that when you all are also when the Senior batch, they'll be finishing the syllabus July end. From July end onwards, your results will come. Then you'll be class will be from morning 8 to 12:30. Okay. Your results will be out, I think, in July. They want to start the schools earlier. Okay. Well, starting school no next week. How many people are starting school next week? See, everybody start. Yeah, that means June 4th. Yeah, you have to do. Everywhere in Sri Lanka, all the students are starting school June 4th. Right, finished. Area, volume, linear density. Anybody still writing this? Anybody still writing? No one? Okay. Right. So next week onwards, we can start solving problems in your tute. Next week, I'll be doing the dimensions part and applications of dimensions. Please don't miss it. This section actually, the units and dimensions part is A-level MCQ 1 mark. So next week you can solve the past paper problem. So next week, make sure you don't miss it. From 1970 onwards, all the past papers will be done. So make sure you don't miss. Right? Anybody still writing? Quickly write. Right. Okay. Anybody still writing? No one? So remember, every week you'll be adding something to your knowledge, which is important for your final exam. Work done check. Your final unit. So what you wrote now? Then okay. Yeah. Have a look and write. Okay. Anybody still writing? Right. Okay, no. No, I had to give a special note. By the way, if you are continuing the class, you should have two books. One is to write the theory. One is to do tute problems. Don't do tute problems in the middle of the theory book. Your theory book should continue nicely. Yeah. After every section, it should continue. Different books should be there where you can put the tute name, tute page number, and start solving problems. Two books. Okay, no? Whether it's single rule, double rule, no rule, I don't care. As long as you have a book. Some people write in A4. People who write in A4, remember, properly secure the A4 and keep. A4, if you missing, the whole lesson will what? Miss. Some fellows, they bring A4 and come, they'll write and go. Then in the shop, when they are eating, they'll keep the A4 and go. The shop fellow will see, these some paper, they'll put in the dustbin, finish. A-level physics syllabus in some fellows dustbin. Okay? So that's why I write in a book. Right, that's a special note here. That's a special note. Now remember, all your MCQ papers are made from special notes. If you are here till the very end, there's about 963 to 964 special notes. That is your A-level MCQ paper. That's how the A-level paper MCQ paper is made. So when I write special notes separately, write it, go home, write it in a separate small notebook and keep at home. When you're going for the exam, you can look at those special notes and go. Okay, that's right. Special note here. Values are unitless. Values are unitless. Values are unitless, which is represented by numerical 1. Which is represented by numerical 1. Which is represented by numerical 1. Okay. So values means what? Half, quarter, 3/4, pi, whatever values, cos theta, sin theta, tan theta, whatever values. No? Any value is going to be what? Unitless. Unitless means how much? 1. Okay, no? Unitless is 1. Put example. Sin 30, cos 30, sin 12, tan 12. Put whatever you want. Sin 30, cos 30, tan 30, comma, half, 3/4, 1/8, pi over 7, whatever. Dot, 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 etc. All those are values. All those are values. Right. Finish now. These two. Pressure, frequency. Pressure, frequency. pressure, frequency. Okay. 1 divided by periodic time per second. Pressure is also called stress, kg, m minus 1, s minus 2. Okay, no? Right. So next week we start sharp 10:30. Please be on time. And we'll continue. Okay then. Get home safe. Right now. If you have any doubts, you can stay back and ask, but I'm sure there is no doubts. Next week you will have doubts. Is it? Okay then. Get home safe. You can all straight go behind from the back door. Otherwise, you might get blocked here. The back rows can quickly go from the back door. Others can follow and go back door. Okay, no? Okay then. Get home safe.